What would happen if the Earth was much, much closer to the Sun? So close that an entire year passes by in a few hours. So close that gravity has locked one hemisphere in a permanent searing daylight and the other in eternal darkness. So close that the clouds rain lava. Although none of this seems possible in our solar system, rocky planets like Earth are not uncommon in the Milky Way. What are the surfaces and atmospheres of these planets really like? Tag along as we are going to talk about how NASA's James Webb Telescope is about to provide us some answers. The James Webb Telescope has discovered two new super-Earths that will shock the entire space industry. The telescope has been in space for around 6 months, which is just a fraction of the time NASA spent in designing and building it. NASA reports that the telescope's instruments to be a diffraction limited, which means that it is as good as it can get, or it can possibly be, given the size of the mirrors, of course. Recently, the James Webb Telescope has reported the discovery of a mysterious cosmic light in space. This achievement was confirmed by the infrared cameras, which help in aligning 18 mirrors to form a fresh, clearer lens. This could be a boon to the study of the exoplanets that are too dim to be observed in detail. However, Webb has a much larger than hugely successful Hubble Space Telescope. It can peek deeply into the infrared part of the light spectrum, which will be quite helpful in uncovering new Earth-like planets. Exoplanets will be one of the targets of the James Webb Telescope's Cycle 1 round of observations. Cycle 1 also includes observation of specific groups of astronomers. Around 2,000 proposals were presented to use the James Webb's telescope in the first stage, among which only 266 were selected by a time allocation committee. Now with its mirror segments aligned and its scientific instruments undergoing calibration, NASA's James Webb Telescope is just weeks away from full operation. Shortly after the first observations are revealed this summer, the telescope's in-depth science will commence. The investigations for the first year comprise the study of two hot exoplanets termed super-Earths based on their size and rocky composition. The Webb's high-precision spectrographs will be trained on these planets with a view to understand the geological diversity of planets across the galaxy, as well as the revolution of rocky planets like Earth. The exoplanets are then classified as super-hot, super-Earth Cancri E55, and cooler super-Earth LHS 3844b. Super-hot, super-Earth Cancri E55. The Cancri E55 orbits not beyond 1.5 million miles from its sun-like star, completing one circle in less than 18 hours, with its surface temperatures far above the melting point of an average rock-forming mineral. The day side of the planet is presumed to be covered in oceans of lava. Planets of this nature are usually said to be tidally locked, with one side facing the star at all times, resulting in it being the hottest spot on the planet. But observations from NASA's Spitzer Space Telescope suggest otherwise. The hottest region is offset by the part that faces the star most directly, while the total amount of heat detected from the day side does vary, which makes scientists question if the Cancri 55e has a thick atmospheric layer. A conclusion of this observation is that the planet has a dynamic atmosphere that moves heat around, that it could have a thick atmospheric layer dominated by oxygen or nitrogen, clarified by Ren Yu Hu of NASA's Jet Propulsion Laboratory, which is located in Southern California. This is the person who leads the team that will use the Webb's near-infrared camera, or NIRCam in mid-infrared instrument, or MIRI, to capture the thermal emission spectrum of the day side of the planet. If the planet had an atmosphere, Webb has the sensitivity and wavelength range to detect it and determine what it is composed of, mentioned Hu. In addition, there is also another conspiring possibility by Alexis Branddecker, according to which it is raining lava in the evening on the Cancri 55e. But the planet is not only tidally locked, instead it would be like Mercury rotating 3 times for every 2 orbits. As a result, the planet would have a day and night cycle, which explains why the hottest part of the planet is shifted. Just like on Earth, it would take some time for the surface to heat up, and the hottest time of the day would be in the afternoon. Hence, Brandecker's team plans to test this hypothesis using NIRCam to measure the heat emitted from the light side of the Cancri 55e during a different orbit. If the planet has 3 or 2 residents, they will observe each hemisphere twice and should be able to detect any difference between the hemispheres. In such a scenario, the surface would heat up, melt, and even vaporize during the day, forming a very thin layer of atmosphere that Webb could detect. In the evening, the vapor would cool down and condense to form droplets of lava that would rain back into the surface, turning back into solid rain again as the night falls. Cooler Super-Earth LHS 3844b. The second exoplanet on the list is the cooler Super-Earth LHS 3844b. Volcancry 55e will provide insight into the fascinating concept of the world covered in lava. LHS 3488b will provide insights into the solid rock surface of an exoplanet. Just like the Cancri 55e, LHS 3488b also orbits extremely close to its star, completing one revolution in about 11 hours. However, because its star is comparatively small and cool, the planet is not hot enough for the surface to be molten. In addition, the Spritzer's observations point out that the planet is very unlikely to have a substantial atmosphere. So, what do you think that the surface of the LHS 3488b will be like? The lack of a covered atmosphere makes it possible to study the surface with spectroscopy. It turns out that different types of rocks have different spectra, as explained by Laura Kraidberg of the Max Planck University for Astronomy. Kraidberg's team will use the MIRI to capture the thermal emission spectrum on the day side of the LHS 3488b and compare it to the spectra known to rocks like basalt and granite to determine its composition. The spectrum could reveal the presence of trace amounts of volcanic gases, so that the importance of these observations goes far beyond just 2 or more than 5,000 confirmed exoplanets in the galaxy, and they will give us fantastic perspectives on Earth-like planets in general, helping us learn what the early Earth might have been like when it is way hot like these planets are today. Therefore, these observations of the exoplanets as a whole will be a part of the Webb cycle in one general observation. Comment down below your thoughts on the discovery of NASA's Webb telescope.